Okay, it's kind of, there we go, we can see a little more clearly now. Okay, y is equal to cosecant of x. To graph this, we will draw our x and y axis. I put 4 tick marks to the right, and I will label this 2 pi. 4 tick marks to the left, and I'll call that negative 2 pi. I'm going to actually label every tick mark because we're going to be interested in where the asymptotes occur. So this is pi over 2 and pi and 3 pi over 2. And on the other side we have negative pi over 2, negative pi, negative 3 pi over 2, and we have 1 up here on top and negative 1 here on the bottom. Alright, cosecant is a reciprocal of sine, so I'm going to sketch in the sine function first. Remember, sine goes through the origin, like original sin. You can remember sine goes through the origin. If you kept graphing this, it would just keep going on and on. So it'd be here, then it would reach the maximum, cut the minimum, reach the minimum. Anyway, so it would kind of go like this. Let's say I stopped right here. Then on the other side it does the same thing. It reaches the maximum, cuts the origin, reaches the minimum, cuts the axis, reaches the maximum, cuts the axis. So on the left side it looks rather like this. If I kept on going and put another tick mark, it would reach the minimum here and look rather like that. Alright, and everywhere it crosses the x-axis you are going to have a vertical asymptote, because remember that sine helps us to draw our cosecant function because it's a reciprocal function. Sine is a reciprocal function to cosecant. So I am sketching in my vertical asymptotes. And if you notice, they occur at negative 2 pi, at negative pi, at 0 pi, at 1 pi, at 2 pi, at 3 pi, at 4 pi, etc., etc. Okay? And then when we actually graph the function, they share minimum point, and they share the sine function and cosecant share maximum points. They share the minimum point there at 1, and then up here like this, and down here. When we list the domain, we have to consider where do the vertical asymptotes occur. So x such that x does not equal, and we could call them integer multiples of pi. Integer multiples of pi. X such that x does not equal integer multiples of pi. The range will be y such that it goes from negative infinity to negative 1, union 1 to infinity. Alright, it's going to have a fundamental period, of 2 pi. If you are asked where the vertical asymptotes occur, you could say vertical asymptotes occur, because on your test they may ask you this several ways. They might ask you what is their domain, and you could say x such that x does not include integer multiples of pi. They might ask you where do the vertical asymptotes occur, and you could say they occur at integer multiples of pi. They might ask you, where is the cosecant function undefined? It is undefined at integer multiples of pi. Okay, that's kind of the real critical question here. It does have a fundamental period of 2 pi. It is the reciprocal function of sine. So if you notice, sine is what I dotted in there. When you look at the pictures on your test, they will not show the sine function dotted in. They'll just show these little parabola things occurring kind of out of the blue. This is how you determine where they happen, though.